Today I'd like to talk about GenServers and Elixir. These things are super fun, and I think they are a cornerstone of Elixir programming. To start, GenServer means generic server. They're basic. So to be a generic server, they have to abstract the common client-server interaction. That is to say that they'll hold on to some kind of state, and there will be callback functions that handle messages that arrive to the GenServer. So if a client asks for the state, the server can return the state. And if the client asks the server to do something, the server will do it. To be able to implement a GenServer is much more simple than it might seem on the surface. If you're already familiar with Elixir, this will feel quite comfortable. Many things in Elixir are modules. The modules can have behaviors defined in them that make them more like a process with a set of instructions for how it should exist. For this video, I want to show an example of a simple Russian relay GenServer. We'll implement a GenServer that holds onto a list of bullets, and we can fire the bullets from the gun, producing a click and bang message respectively. If the bullet bangs, then the GenServer will be stopped. And to add a little flavor onto this, it's going to be a quantum Russian relay gun, which means it'll generate all of the possible states that the bullets could be in. Alright, so the first thing we're going to do is we're going to mix phoenix.new Russian relay --no echo, because we don't need a database for this project. We're going to take the default option shown with the capital Y and install dependencies. That'll take a moment. Over here already, you can see in our project, we've already made the Russian relay. We can see here we've got a library that's going to have our web, and it's going to have our application, just the Russian relay plain. We're also going to have this generated with some tests. We got some test helper that starts X unit. We've got some support tests over here. And we have tests for our web pages, like our page controller test that shows that, yep, we can get our page, and it'll show this text in it. We can get some error when there's a 404 or 500. And we can get the web page for an error, 404 and 500. One is JSON and one is HTML, so we have them in both. We're going to write a few tests for this project. So the first thing we're going to do is we're going to write our quantum gun. I'm going to make a new file, call it quantumgun.ex, and then we're going to def module, Russian relay, quantum gun, and we're going to make this a GenServer, so we're going to use GenServer. When we use that use keyword, we're going to inject any code in the current module, such as importing itself or other modules and defining new functions. So when we say use GenServer like this, we get access to functions that are in the GenServer. You can see that on hex docs. So here in hex docs, we have our GenServer, and this tells us some stuff about the GenServer. You can read up on it. But when we use GenServer in a module, we're kind of turning that module into a GenServer. In that way, we get access to these callbacks. We get access to these functions that are there in the GenServer. Primarily, though, we need to use these callbacks to set up our GenServer. Actually, you can see here is a simple setup for a stack GenServer in the hex docs. So here they use GenServer, and then they make an init function that takes in some sort of elements, and then it'll set those elements to be the initial state by doing a string split on those elements. It's a comma-separated list of elements, I guess. It'll trim off any white space, and then it'll set that state. It uses this impl keyword, where it's saying that this is going to be implemented exactly like how it's supposed to be here in the GenServer docs. So where init is saying here that it's a callback, and it takes in some sort of term, which is a way of saying anything, and it'll return an OK state or some OK state, timeout, hibernate, continue tuple, something like that. Could return an ignore, or it could return a stop reason. And so when we write our init function, it'll be exactly like that. And you can see here it's just an OK and some term, so this OK and some state. And then they implement a handle call, which means because we see the impl true, it's going to be implemented just like this, where it takes in some requests, which will be a term. It'll always have a from, and it'll always take in state. And then when we return, we should reply Atom, and then reply, and then a new state. Or we can reply with a reply, some new state, or timeout. You can read all the way down through this. You can technically not reply. You can also stop the gen server. So we'll go back up to this simple implementation and look at the last thing. We've got a handle cast. Maybe we should talk about the handle call, actually. So here in the handle call, we've got a pop. So we get a pop message from somebody, and in this case, we don't necessarily care who it's from. We take that state, and since the state is going to be some list of elements, when we pop, we're going to take that thing off the state, reply it back to the caller, and then set the new state with the transformed list. And then if we handle cast here, that means casting is different than calling. So let's go take a look at casting. When we cast, casting only does no replies, or it might stop. There's a pretty big difference between calling and casting. Although in calling, you can no reply, with casting, you can only no reply. So it's good to know those differences. It kind of depends on what it is that you are trying to do with your gen server, and there's a reason for the difference. So give it a try. It's some good stuff. So we back up to our gen server. We'll handle cast. In this case, we give it a push message, and we're pushing some element. And so we're going to take our state, and then we're going to append the element to the head of that list. That'll be our new state, and then we set the new state, and we don't reply. That means for somebody who's just pushing something onto this little gen server stack, they push, and as long as they get some okay, then everything went fine. Right underneath our example stack, we see that we can start a gen server by doing a start link, and then we can do gen server call and pop, and we get like a hello, because we gave it hello in world. And then here we do a gen server and cast and push Elixir, we get okay, and then we gen server call pop, and we get Elixir back. Casting is good when you get okays. That's practically all you get back from casting. It's only when calling, when you want some sort of specific reply. So back here in our gen server module, we're going to define some of those server callbacks. I have a broken A key, please excuse me. We're also going to define a client API for interacting with the gen server. And then we're going to also implement some private functions. So the first thing we're going to make is our start link function, which will be how somebody starts the gen server. And because it is a quantum gun, we're going to have to set up a superposition of states. For us to start it, we're going to do genserver.startLink, give it our module, and some initial argument, which will be an empty magazine. So we'll make call it a revolver. Let's just call it a magazine. So we'll give an empty magazine to start off. And then to implement our server callback, we'll implement a def init. The reason why is because when we do start link, we can see here in the documentation for it, that once a server is started, the init function of the given module is called with the init argument as its argument to initialize the server. And so in this case, we do start link. That'll take us to our init function, and we're giving it the magazine. And we're going to say, if the magazine is some empty list, then we are going to make some possible states for magazine. That's going to be equal to some function. We're going to generate possible states. And then we are going to okay and return our possible states for the magazine. That should be our init function. Yep, returns an okay and a state, and that's going to be our state. So what we're going to do is we're going to make our generate possible states function. So we'll def p generate possible states, and for this we're going to make it a little configurable. We're going to make it do 6 shots. Then we're going to enum.map 1 through n, and then that's going to give us our live position for our live bullet. And what we're going to do is we're going to generate our blanks, be a list duplicate blank for n, so that makes 6 blanks. And then we're going to list.replace at in our blanks, our position -1, our live bullet. So that'll generate the possible states for our quantum gun. We can go ahead and test this too by going into IEX and just pasting that in there. Oh, it doesn't have our n, so we need to n equals 6, paste that in, then we get our bullets, all of them. We can do n equals 1024, then we can paste that in, we get a whole bunch. So now we want to add in our client API a function to fire the gun, where we're going to GenServer.call. We're going to call, we're going to have to give it PID. We're going to call the PID with the message fire. When you make a GenServer, it's going to have a process ID number, and that's how you can find it in the supervision tree that is your application. So when we do start link, it's going to make a PID, but then we're going to have to take that PID and find it again later. And I'll show you how to do that, or at least a way. There's a better way. This is not going to be the best way. So we make our fire function on the client API, and we're going to define that in our server callbacks with def handle call. That's going to be our fire request. Oops. We don't care who it's from, and we do want that state. And then we are going to reply with some sort of message, and then we are going to collapse quantum state. So right now we've got a quantum state, and then we've got to collapse it. So to collapse it, we're going to enum.random our quantum state. It means we simulate grabbing one at random. That'll be our collapsed quantum state. And then what we want to do with that quantum state is we also want to make sure if the gun was fired or not. So we're going to do a case statement where we're going to case on our collapsed quantum state, and if the bullet is live, we'll call this the rest of the collapsed quantum state. Call this remaining bullets. That might be better. There we go. So we'll return our remaining bullets. So if it's live, we're going to say bang quantum state collapsed to a live bullet. Where if it's blank, we're going to say click quantum state collapsed to a blank bullet. I think that'll work. Then we get back our remaining bullets. And so if somebody fires it again, we're not just going to enum at random anymore, which also means that we have to do something a little more specific about our possible bullets. So we're going to label them as being in a super position, like this. So then when our function is being worked on the first time, we know that this was a superposition of our quantum bullet state. That might be better. Quantum bullet state. And then we collapse it, and then we check if there's a live or a blank, and then we return our message. Let's see. So what we want to do here, we want to make our reply here and here, and this will be our reply message, like this. So here we're doing our case where we work on the collapse state. We're doing some pattern matching where we're saying if the head of this list is a live bullet, then bang, we just shot a live bullet, and we'll take those remaining bullets and put them to the state. And if it's a blank, we get a click. Then we take those remaining bullets and put them to the state. So now, if the gun gets fired again, and naddle, I gotta fix my keyboard. So if the bullet gets fired again, we're going to get our fire message. We don't care who it's from. We'll get that collapsed bullet state. We could actually do this a little more quite simply than what I'm probably about to do here. We can do it like this. We're going to take our case like this. What I'm thinking about, though, for those who are curious, is we could do a pattern match where we say, if this is live and remaining bullets, then maybe this might be better. Then we reply like that. And then we take this. You might see where I'm going with this. We can take this and then handle call when it's fired. I don't care who it's from. Say blank remaining bullets. have something wrong here. So we can be like that. So when it's fired again, if our top bullet is live, we take our remaining bullets, put them in, and then we reply back with bang. If it's a blank, we take our remaining bullets and we put them back and we reply back with our blank. And then we have one more situation for when we fire, and that's when our bullets are empty. So we'll say the gun is empty. Okay, so we're going to change this remaining bullets to also be an empty list. And then we're going to look back up here. I'm going to look at magazine really quick. Let's make this magazine argument superposition. And that should wrap up our gen server. And so now we can make some tests. So we're going to make a folder called Russian Roulette. And in that folder, we're going to make a file. We're going to call it quantumguntest.exs. Here we're going to def module Russian Roulette quantum gun test. We're going to use xunit.case. And that makes this a case the same way using a gen server makes the other module a gen server. And so we'll write a describe block where we're going to describe our start link functions. And we also want to describe our fire function. So we're going to write a test in our start link for our gun being able to start up. So we'll write test and start the gun gen server. And then we're going to assert OK and PID for Russian Roulette dot quantum gun dot start link. We can go ahead and mix test on that. So it looks like that passes. So we can assert process.is process alive PID. Run that test. Cool. So we can see that things are working when we do start link. Now we want to write a test. Actually, we need to clean up here before we write a test. So now we need to clean up. At the end of our test. And so we'll do a GenServer.stop. So now we need to clean up at the end of our test. And so we'll do a GenServer.stop. And we're going to stop our PID. That way it cleans up the gen server. And we're going to assert OK about that. So let's mix test. Cool. So it looks like that's working. So we're going to go ahead and write a test for our fire. All right, so next we're going to write our fire function test. We're going to test that it can handle a quantum superposition state. And how we're going to test that is we're going to start one by doing quantum gun.start link. So we'll start one, and we will give it no arguments. So we'll get our OK and PID, and then we will try firing it. So we'll do an assert result Russian Roulette quantum gun dot fire, and we'll give it our PID. And then we'll want to assert that the result contains in it bang or click, right? Because we've got bang here and click here. So we'll want to assert that. We'll also want to assert that the result contains quantum state, how do we write it? Quantum state collapsed. Let's go ahead and run our test. Oops. So it looks like that works. Cool. Cool. We can test that too by putting a debug here, and then mix test. And we see, yep, we got a click, so the gun did fire. That's cool. So now we want to add a test where if it has an empty chamber. So let's test handles empty chamber. We'll do assert OK and PID is equal to relay quantum gun dot start link. But this time we're going to give it an empty list for our magazine, which means too that we'll have to make a start link function that takes in a magazine. We'll do like that. You know what I'm thinking is that we can do a magazine or blank like this on our start link. Yeah, that should work. Then we give it a magazine, and here we're saying if the magazine is some empty list, but in our init, let's do if our magazine is like a real magazine, not just some empty list, then we don't generate possible states, and it's not in a superposition. We just give it the magazine. So that should work. So we'll do assert Russian roulette dot quantum gun dot fire. We'll give it our PID, and then we should get some result. And I'm not 100% sure what that's going to be. Let's see. The gun is empty. That's what we should get. So we'll assert that result is equal to or contains. We're going to check that it contains the text, the gun is empty. We can go mix test. Let's see. So our magazine went in, and we got a click. So let's see what happened. Right, so it matched on this, and then it generated all the possible things instead of doing this that I thought it would do. So what we could do is we could put in a blank, and then we can fire it twice. This probably isn't the best way that we can test this particular thing, but this would work. So we can mix test. Let's see, assert result. Oh, we don't have result. There we go. So it does fire twice, and it does look like it works. We can prove that by doing like this. The gun is empty. When it's empty, like that, we can have this test. Let's see. When no magazine given produces a quantum state of bullets. There's probably a way that we can fix this up, though. Let's see. What about if our start link is given nothing, then we give the superposition atom, and if this is in superposition, then we generate all the possible states. But if our start link is given some magazine, then we do something different. So now we can say, we can just fire the gun once, I think. Oh, we got a click. Oh, because of this, right. We want to remove that. We still got a click. What happened? Let me check this. Yeah, I want to check this. Let's look at this init. Debug magazine. So we're not hitting this case clause because we want to give it an empty magazine dir. Okay, well, we can keep that there just to show ourselves. We wanted to put an empty list right there, so we'll mix test, and then cool. So it fires and it says the gun is empty. So now we've got a way to do a superposition on the magazine, or just give it some magazines so we can test like, okay, it's got an empty chamber. And then we can test that, let's see, we can test that the gun process stops on live bullet. So we can test that. And with that we'll do an OK PID Russian relay dot quantum gun dot start link. missing the equal sign, assert, start link, we'll give it a live bullet, and then we will fire, and we'll assert that the result says bang. And we will also assert process.alive, give it our PID. So we'll go ahead and save that, and then run test. Let's see. Quantum gun, I misspelled, miscased it. There we go, so that works. So in this test, we can see that our quantum gun stops on a live bullet. It's no longer live. And then we want to test process continues on a blank bullet. So we'll essentially take the same test, but we'll give it a blank bullet. We'll fire, we'll expect click, and we'll assert that the process is still alive. So next test. Oh, you know what? This test, the process is not actually dead, is it? It's still alive, huh? Yep, it's still alive. We don't actually want that. So if it's a live bullet, let's kill the gen server. So we'll do a stop normal. That's our message, and that's the state. So if it's a live bullet, we'll do that. We'll have to do that here as well. So we'll stop normal. And then let's run our test. Yep, there we go. That's now false. That's what we want. So we'll refute that the process is alive. So now when we run our test, see, okay, so the gun stops on a live bullet, and the process continues on a blank bullet. And I think there is one more test we'll want to write. Now that I think about it, we probably want to do the cleanup at the end. So on the end of these, we'll do a stop gen server just to clean things up. The gen server would otherwise be alive. Well, in this case, it's going to be dead, so we don't have to stop there. We can do it like that. And we can mix tests and make sure that things still work. Alright, so now that we've got this test done, let's go ahead and make a live view so that we have kind of a UI to play with our gun game. So we'll make a new folder and call it live, because that's where live views are going to go. And we're also going to go into our router. We're going to add a live/gun game live.index. I had already done that here, so I'm not going to be typing it out, but we can see it here. And so here in our live folder, we're going to add a new folder called gun live, and we're going to put in that folder a new file, index.ex, and we're going to put in an index.html.heaps. We can put hello world into our index here, and for our LiveView index, we're going to write up def module Russian roulette web gun live.index, and we're going to use Russian roulette web LiveView, and then we're going to @import true, and we'll def mount. This is a mount for when somebody connects to the page. We'll get this socket, and we're going to OK and give back the socket. This should give us a pretty standard page to look at. We can go ahead and test this by going into IEX-xmix phoenix.server. Oops, I'm in the wrong folder again. CD Russian roulette. So we'll go ahead and build that, open that, and then we'll go ahead and open it in our web browser. And here we can see in our web browser we've got our Phoenix app running at this home page. This is just the default, but we're going to go to gun game. We can see that, oh, we forgot to do something. Roulette index is not available. Index live is not found. Let's take a look at our code. Oh, this should be called gun game live. Let's rename our folder to
Here we can see in our web browser we've got our Phoenix app running at this home page. This is just the default, but we're going to go to gun game. We can see that, oh, we forgot to do something. Roulette index is not available. Index live is not found. Let's take a look at our code. Oh, this should be called gun game live. Let's rename our folder to gun game live. And now we should be able to see our hello world. So what we forgot to do was to call it gun game. So we'll call this gun game live, and then we should see hello world. So cool, we've got a web page going. So now that we've got a web page going, we're going to go ahead and set up a couple of things. Back here in our code, we're going to go to our web page, and we're going to write in some Elixir, some embedded Elixir. So we're going to do an unless the game is started, then we'll do a button where when we click it, a Phoenix click, will play Russian Roulette. We're going to give our button a label, play Russian Roulette. And we're also going to say else and unless the game is over, then we're going to do the button Phoenix. With a Phoenix click, our Phoenix click is going to be fire gun, fire, touch button. We'll do else, do button, Phoenix click, play again. This will be if we die, then we get a play again button. And then we'll end. And then we'll add a little break right here. Some people don't like that. I think it's okay. Just for what we're doing. Text black. We'll add our game log down here. So this will be messages that we get back from our gen server. And then we'll end. Cool. So let's kind of go over this a little bit. So what we're going to do is we're going to have our page, and if the game, unless the game is started, we'll offer the button to play Russian Roulette. And if somebody clicks that, unless the game is over, they'll have the option to fire the gun. If the game is over, the option to play again will show up. And down here we'll have some game log that'll show messages from our gen server. So let's go ahead and get this implemented. We'll go into our index here, and we'll have to implement a few things. First, we'll want to assign to our socket some default state. This is a LiveView socket, so this is not the same as a Phoenix connection. There's some differences. Can go into that maybe in a different video. We're going to need a handle event, just like our gen server. Actually, I don't think no, we didn't do a handle event in our gen server, huh? No, we do a handle call. But a handle event is going to be something very similar to like a handle call. So in this case, we're going to want a handle event for play Russian Roulette. So like our play button, we'll want to have an event for that. And these Phoenix clicks are all going to basically broadcast events, huh? So this Phoenix click will do play Russian Roulette, and this Phoenix click will do fire gun, and this Phoenix click will do play again. So these will be our handle events that we'll want. So we'll make a handle event to play Russian Roulette. We'll make a handle event to fire gun, and we'll make a handle event to play again. These handle events also take in parameters, multiple parameters similar to a gen server. So we'll get some unsigned parameters and our socket each time. So we'll go ahead and add those to these. We can also say @impl true, because we're going to implement this the way it should be for a LiveView. And what we want to implement is a no reply socket, but we are going to change the socket each time on each of these events. And let's make our assign default state. So we'll assign our default state of the page of the socket to take the socket, and we'll assign, this is a keyword that comes in from LiveView, we'll assign a key game started, and we'll give it a value of false. we'll also assign a game over and give it a value of false, and we'll assign a game log and give it a blank string. And so this might change, this might fix some things that we had in our HTML. You might notice so we scroll up here, this red text. We got this red text because the variables that we set, like the key game started, was not found. But now it should be found, because when we mount, we assign this default game state. We give it a game started as false. So we can go and look at our page. We can see that we've got our play Russian roulette right there. And now we're going to go ahead back in our code, and we'll set up how we want to play the game. So the first thing we'll do is we'll do an OK and PID, just like we did in our test, for our Russian roulette gun. We'll start link. So that makes the gun a child process of this parent process, which means that the web page that we're looking at, this page, is running some process. That is what a LiveView is. It's like a gen server. It's a process. And when we start link to our gun, we're making a child process under that page. We're going to take our socket. We're going to socket. We're going to update the game started variable, where if it's false, it's now true. And we're going to assign a new key to our socket, the game PID. We'll just PID like this, a function that just returns the PID. And that makes our socket, and then we will apply the socket to the, we'll no reply with the socket. And so what this should do is we should be back here in our page, and we should be able to start the game. So I'll go ahead and click. Looks like something broke when I did that, so let's see what red text we get. And the module gun is not there. Oh, that's right, because we called it a quantum gun. So we'll recompile. Let's go ahead and click on this. So we click, and cool, now we've got our fire button. So we'll have to put in our logic to make the gun fireable. So let's do that next. So to make the gun fireable, we will we'll make our gun is equal to socket.assigns game PID. So that's our game PID off of the assigns. We make a gun. And then we'll do a result, just like in our test. Russian roulette dot quantum gun dot fire gun. And then we will say if the result has bang, or the result has no bullets left. We might not actually have to do it like this. We could do, I think we could do this. I think that'll work. We can do socket is equal to socket, and we'll update our game over state, where whatever it is, we'll make it true, and then we will update our game log, where whatever it is, we'll put the result, and then we will no reply and socket. But we also, so that's if we die or there's no bullets left, but let's say that we do fire the gun and we don't die, then we'll want to socket, and we'll update our socket's game log, where we'll just put the result, and then no reply and socket. So that would make our fire gun function. So we can go back here, we can play Russian roulette, we can fire the gun, and click, quantum state collapse to a blank bullet, and would we like to play again? See if the play again button works. Nope, it broke. So let's see why it broke. What we've got is our play button and the fire button. So we can hit play and hit fire, and then we get click and then play again. So that kind of works, I think, except that our gun seems to be empty-ish, as in there's no bullets, and there should be bullets, and when we click to play again, it breaks, and we can see that we get a no function for handle event, play gain. I mistyped that, so we won't do play again. So let's fix that, and then go back to our page, play, fire, play again, play again, play again. Okay, we kind of get nowhere with our play again, but it is doing something because it now works. It's just we're only doing this. So we'll have to set up our play again and also figure out why it is that the gun is only clicking when it should be doing more than clicking. It should also be banging. So let's go ahead and do an OK PID to set up our play again. Let's set that up. So we'll do a Russian roulette dot quantum gun. Let's start link. And then we will take our socket and we will update it with game over, function true, false. And so if our game over was ever true, it's now false. And then we will also update our game PID with the new GenServer PID. And we will also update our game log by clearing it from whatever it had in it before. And then we will null reply in socket. So we'll go ahead, play Russian relay, fire, click, play again, fire, click. Okay. What we've got is our play button and the fire button. So we can hit play and hit fire, and then we get click and then play again. So that kind of works, I think, except that our gun seems to be empty-ish, as in there's no bullets, and there should be bullets, and when we click to play again, it breaks, and we can see that we get a no function for handle event, play gain. I mistyped that, so we want to play again. So let's fix that, and then go back to our page, play, fire, play again, play again, play again. Okay, we kind of get nowhere with our play again, but it is doing something because it now works. It's just we're only doing this. So we'll have to set up our play again and also figure out why it is that the gun is only clicking when it should be doing more than clicking. It should also be banging. So let's go ahead and do an OK PID to set up our play again. Let's set that up. So we'll do a Russian relay dot quantum gun. Let's start link, and then we will take our socket and we will update it with game over, function true, false. And so if our game over was ever true, it's now false. And then we will also update our game PID with the new GenServer PID. And we will also update our game log by clearing it from whatever it had in it before. And then we will null reply in socket. So we'll go ahead, play Russian relay, fire, click, play again, fire, click. Okay. So now we need to figure out what's going on with our gun and why it's only clicking. So let's see, there's something about how we started up the game, possibly. So we Russian relay, quantum gun, and start link. And when we start link, we know we can get all kinds of things. So let's see, start link with no parameters gives us superposition. We'll generate all our possible states. But for some reason, we are getting an empty list. Superposition. Let's see if we're even getting here. I'll say debug superposition, recompile, and then let's fire. Let's get a new game, let's play again, fire. See if we got our debug statement. We did, we got a superposition. And it's not generating possible states. Let's take a debug at that. Play again, fire. Oh, I need to recompile. Play again, fire. Oh, let's see. So we get our states, possible states. We fire. And we want to enum random one of these. Let's double check that that's working. So recompile. Play again, fire. Let's see, random. Okay, then that goes into our case, which will figure out if it's a stop or if it's a reply, which in this case it would be a click. Let me take a look at this. Unless the game is over, fire gun, or play again. Play again, bang. Okay, so we got a bang this time. Oh, but we're getting the fire, the play again. Hold on, there's something wrong with our game over state. That's what I think might be wrong here. So let's see. The game is started. Unless the game is over. Let's take a look at this again. Play Russian relay, fire, click. Play again, fire, click. You know what? We want to know the state of our socket. That might help our situation. So let's take a look at our debug socket assigns when we fire the gun. So we'll play, fire. What do we get? So when we hit fire gun, the game is not over. We get blank, 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 blank. We might want to switch our button positions. Is probably what we want to do, huh? Once the game is over, fire and play again. Let's take a look. Oh, that's not what we want to do. What are we doing? So we fire the gun. If the result has bang or no bullets, let me take a look and see if we have to do result like this. Let's give that a try. Let's see, play Russian roulette, fire, bang, play again, fire, click. Okay, here we go. So now when we get the click, it sticks on fire. So we just fired a few times and then bang, we got shot again. We could also probably set up a little way to see how many times we fired the gun. So let's go ahead and just exercise doing that. So let's see. We'll add to our state, assign times fired, set that to 0. And then our fire gun, every time we shoot it, we will update the times fired key, where we'll get that number, and we'll just add 1 to it. And then we can put into our game log here, we can add a break, just to put a little space. We can say, this is our times fired on our gun. Yeah, that might work. So we'll take a look at our page here. We'll click, play game, we'll fire the gun, click, fire 2 times and bang. Play again, fire, click, play again. See, we need to reset our number counter when we play again. So we'll go ahead and we'll update times fired, and whatever number it was, it'll now be set to 0. So then we'll play, fire, play again, fire, 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 fire. Oh, I didn't make it to 6. Play again, fire, fire, oh, fire, fire, fire. Might actually get a little fun. Ooh, that means I survived the game. It's a 6 shot, and I survived all 5. Bang. All right, cool. So we've got a working little LiveView game, and as it would turn out too, we can test this. So to test this, we'll go to our test folder and the Russian roulette web, and we will add a folder for live, and we will put in a new file for gun game live test.exs. Then we'll def module gun game live test, and here we can write some tests like, let's see, what kind of test do we want to have? We'll do we've got to use, we want to use Russian roulette web con case. Then we'll import phoenix.LiveView test, and then we'll describe our index function. So we'll test that the gun page is accessible. It's a test we can write. That'll take in our connection. Let's also write a test for creates a gun game. Take our connection. Pretty much all of these are going to take in a connection, because we're going to be testing the connection of the page, obviously. We're going to test that we can fire the gun. Take in our con. We should test that we can play again. Yep, these should be our tests. So to test that the gun page is accessible, we'll do an assert, we'll do an OK, live index, live, HTML, we'll do live con, we'll give it a path, /gun, and then we're going to assert in our HTML, gosh, I am typing horribly today. We're going to assert in our HTML that we can play Russian roulette. So we can stop our application from running. We can do mixed test. See how that works. Let's see. We got a failure. Plug con 200 gun. Oh, you know what? This is supposed to be gun game. That's right. We called it gun game. For reference, I keep referencing a project that I made as a reference to do this video. So I'm getting tripped up because I'm kind of remixing the reference. But I did make the reference in the first place, so I'm essentially doing this project twice anyways. So now we can test this. We get gun game. We get what we expect. So that means that here in our HTML, we're getting that play Russian roulette. We can also see what our HTML looks like, and it will look like just regular HTML. So mixed test. And you'll see, yep, here's some HTML here, and it's easier to just assert that, hey, in that HTML, we should be able to see the words play Russian roulette. So cool. So we've got that going. So next we want to make sure that it can create a gun game. So we'll assert, okay, our index live. This is technically our live view. I always write live view. So okay, our live view, and our HTML. Give me a moment here. Take our live con from our path, gun game. So let's see, what are we doing with these? We're going to take our index live, and we're going to assert that we can interact with it. So it's going to take our index live, and we'll pipe. Let me move this pipe over a little bit. So we'll pipe. We'll look for an element. That's going to be a button. Play Russian roulette. And we're going to want to make sure that this, we can do a render, click on the button, technically. And what we're looking for is when we click on it, we get a page back that says fire. So we'll go ahead and mix test on that one. So we get our things back, no failures, that's good. So in this way, we've written a test where we say, go to our gun game page, and in the live view, add a button that's labeled play Russian roulette, click it, and then we will get a fire. That's cool. That proves that we can create the game. Let's move on to our next test. We're going to do so we're going to test that we can fire the gun. So we'll assert an okay, and take our index, live view. Again, we're kind of doing some of the same, but we're going to have to go a little further. So we'll do a live con, our path, gun game. And this time we're going to click on our button and fire, and then we're going to click on the button to fire and play again. Yes, because what we're going to be doing here is clicking on the button to fire the gun. So we're going to do much of the same thing. So we'll get our one to start the game, like this. So we'll play Russian roulette, and then we will add another one and say assert our index live, and go to the button where it says fire, and then click on that, and then assert that we get something back that either says fire or play again, because we could die if we fire the gun. And then we will render our index live, and we'll also assert that there is a bang or a click. That's how we can test that we're firing the gun. So let's mix test here. Okay, the process is not alive. Also because the application isn't started on this test. I see what's happening now. We have this cleanup where we're going to say stop the gen server. However, if it bangs, then it's going to be dead, and so there's no gen server to stop. So what we're going to do is we're going to say if the process.alive for our PID, then so if that gen server is alive, we'll stop it. If not, then we don't really do anything else. So then we can mix test. And cool, so now we probably won't get that whole situation again. So that's cool. So now we can fire the gun, and we've got that tested, that we can fire the aforementioned gun. So now we're going to move ahead, and we're going to add a test to play again. So what we'll do is we'll kind of do all the same things. We'll start the game, we'll connect to the page, we'll play the game, we'll fire the gun, but the thing is to get to the play again, we might have to fire the gun a couple of times. So what we'll do is we'll add a defp and then say fire until play again. We'll give it an index LiveView, and we'll do if index live element button fire, and render click. So when we fire, and if we get fire back, so we can continue firing, and then we'll do this function again with our index live, else we'll just give back the index live. That should give us our play again. So instead of firing just the one time, we'll do our index live is equal to fire until play again with our index live. So we'll assert that we can get something truthy back about that. And then we will take that index live, render, and make sure that it says play again. And then to make sure that we can play the button, play the game again, we'll take this button and then press play again. And when we press it, we want to make sure that we can see the fire again. So we'll mix test. And cool, that passes, no failures, which means that as long as our tests are written well, then we now have a completely tested little LiveView and little game thing. We could add other tests to this, such as what happens if there's a failure. And as you've seen, we had a couple of failures as we went along. By failure, we mean just like the red text, you know? So that means technically we could add tests that say, hey, this is a type of scenario that can cause red text. But for our small experiment, this should be fine. So now we can go ahead and just iex-s mix phoenix.server. Now we've got a Russian roulette game that we can play. And I'll leave it up as an exercise. If you want to add to the test a way to test that the numbers increment, go ahead and do that. Thanks for watching.